What's up, people, and welcome to my tutorial in Pragmatic Data Science. So in the previous videos we looked into a use case where we did linear combinations, and in this video we're gonna take a little bit more dive into this and see how we can do matrix multiplications and why and how it is done as it is, basically. So we're gonna start with this theoretical approach with vector multiplication. And this PDF is also included in the repository for the project, so if you want this you can download it or clone it from GitHub. So let's start here. So generally the values that we had previously from our data set, the values here is notated as x and then x1 to x2 to xn. Basically the n here is going to be equal to how many columns are in your data set that you have. And the weights are going to be the one that we manually set with like the decimal places like dot zero and so on. So this is going to be known as theta from how many features you have, basically. And the length of these vectors is going to be the same if you're going to multiply them together. So I've notated here the shape of it. So this is how I would notate shape of vectors and matrices. So first we're gonna have one row and n columns, and this is for the values, and then you're gonna multiply that with n rows and one column. Basically the number 1 here says that it is a vector. So in order to be able to even multiply this, you have these two numbers here, n, they have to match up, they have to be the same if you want to multiply them together, basically. And the outermost values here, 1 and 1 in this case, this is going to be notating how your newly created matrix or vector, what shape that is going to have. In this case, 1 by 1. And you can think of this as a 1 by 1 matrix or 1 by 1 vector, but in practice it's going to be scalar values. It's going to be the number 7 or whatever. And the way it is performed is you take one of these values, just a quick recap, you should be able to do this by your own, but just a quick recap that you take, match them up. So you say x1 value goes together with theta 1 value. So you multiply these together, and then you put a plus between them, and then you take x2 and you multiply it with theta 2, and you do that for each item, and then you sum them up in the end. And that is how you get this scalar value or 1 by 1 matrix. And in order to make this a little bit more precise, and I have an example here. So I have a vector v1 that has its length 4. It has 4 elements here, 2, 3, 7, 1, and this is just randomly picked values. And then I have some other vector here, v2, that has some floating point values in them, and I'm going to multiply them together. So basically this is how you do it. You take 2 here, and then you multiply it with 0.2. This is this section here. And then you take 3, and then you multiply it with dot 0. This is done here. And then you just do that for all the values, all the pairs like this, and then you sum them up. You have this addition plus sign here in between them. And then you get this value almost 0.2. I think this is a floating point error. I think it's equivalent to 7.2, sorry. So this is how you would notate it. And if you want to do this with NumPy, you can go ahead and follow and experiment a little bit with this, but this is how you would do it with NumPy. So first you would start importing it, then you create this first vector here, and then you create this second vector with the numpy.array, and then you use this np.matmul for matrix multiplication. And these are of course vectors, but that doesn't really matter. It can still be considered as a matrix that only has one row or one column. So that is how you would follow along with that. And you can also try and experiment what happens when you switch these around. So you take np.matmul v2 times v1, because that is not going to yield the same value. That's going to yield some other value, because order matters in matrix multiplications. And that is all for this video. I hope you guys liked it, and I will see you in the next video where I will talk a bit about matrix and vector multiplication. Alright, so see you, bye bye.